Hello and welcome back. For this video we'll be discussing linear inequalities and system of inequalities in two variables. There is a PDF for printout if you'd like to follow along. First we'll discuss what is a linear inequality. Well, it's any linear equation in two variables in which the equal sign is replaced with an inequality symbol. That would be this symbol here. The solution to a linear inequality consists of the line itself, possibly, and a half-plane region of ordered pairs that also makes the inequality true. So what I've done in this graph is I've graphed the equation that's actually up here, and you'll see that this inequality does not have an equal to sign, so we leave our line here dotted. A non-equal to sign is akin to an open circle, and in case of drawing a line it would be a dotted line. If I did have an equal to, so a symbol would look like this, which normally is a closed circle, instead of a dotted line I would draw a solid line. Now the region above the line actually contains the solutions. Check that, is to pick a point. Let's say I pick this point right here, which is 0, 0. When I substitute those values in for x and y, I get a 0 is greater than 2 times 0 minus 4. 0 is greater than 0 minus 4. 0 is greater than negative 4, and that is true. And if that's true, you shade in the direction of that point, which would be on this side of the line. Now there is sort of a shortcut to this. This form that's written up here is called slope-intercept form. Whenever you write your equation in slope-intercept form, if the inequality is opening towards the y value, you're always going to shade above the line. So this is the y axis right here, and we're looking for y's that are bigger. And you can see that's above the line, so we're going to shade on that side of the line, which is this direction. Now this is called a half plane right here, half plane, because the entire plane is broken up by that line. And remember, the line is not part of the solution. There's actually another half plane on this side, but the one that contains the solution is actually over here. Now an open half plane is any half plane that contains the dashed or dotted line like we've got right here, because that dotted line is not part of the solution. A closed half plane would be if I were to close that line off, and that half plane would be closed because of the line being part of the solution. That would be an equal to. Example 1, we want to graph 3x plus 2y plus 4 is greater than or equal to 0. Now in order to do this graph, you have to put it in slope-intercept form. That is y equals mx plus b. Basically, you're just solving for y. So the first thing I'm going to do is move the 4 over, so 3x plus 2y is greater than or equal to negative 4. Then move the 3x over. 2y is greater than negative 3x minus 4. And then we can divide everything by 2. So divide by 2. And y is going to be greater than or equal to. Now I'm not going to go ahead and divide my fraction out here, because this fraction of negative 3 over 2 is actually going to be my slope, and then negative 4 over 2 of course is negative 2. This is my y-intercept, this is my slope. So my first dot goes at negative 2, which is right here, and I can go down 3 and over 2 to apply my slope. So go down 1, 2, 3 and over 1, 2, or I can go up 1, 2, 3 and over 2. And since I have an equal to sign right here, I'm going to use a solid line. Alright, now that's only part of my solution. The line itself is part of the solution, but I also have to select the appropriate half plane. I'm either going to choose above the line, which would be up in this region here, or below the line, which would be down in this region here. Now the shortcut again is to go back and take a look at your slope-intercept form. If that is opening towards y, we're looking for all the bigger y's, and all the bigger y's would be up here, so basically we're shading on this side of the line. We don't have to color it in solid. The other way to do this is to test a point, and if you have the point 0, 0, always use it, but if that point is on the line, then don't choose that one. If the point turns out to be true, you shade in that direction. If it's false, you shade in the opposite direction. Example 2, we're going to graph this one. So we want to get it in the slope-intercept form, so the first thing we're going to do is move the 5x over, so I have a negative 2y is greater than negative 5x plus 10. Then I need to divide by negative 2. Negative 2, negative 2, negative 2. Now keep in mind that when we divide by negative on both sides, our inequality will switch, so we have to change directions here. Now I'm not going to divide the 5 and the 2, but negative over negative is positive 5 over 2x, because this is our slope. And then a positive 10 over negative 2 is going to give us a negative 5. This is my y-intercept at negative 5. 1, 2, 3, 4, 5, so I go down to negative 5. And then I'm going to apply a slope of 5 halves, so go up 5 and over 2. Up 1, 2, 3, 4, 5, and over 2. And because it is an inequality without an equal sign, we're going to have a dotted line. So I'm going to use the dotted line to represent. And the last thing I need to do is decide which half plane needs to be shaded. Where are the rest of my solutions located? Well, again, that lies into whether or not the inequality is opening towards or away from the y when in slope-intercept form. Well, it's opening away, so I'm looking for the smaller y values. Well, the line crosses the y axis right there, so up here would be bigger and down here would be smaller. So clearly, this side of the line is where the rest of my solutions will be located. This would be an open half plane because that line is dotted, meaning it's a boundary line but not part of the solution. Here's how we graph vertical and horizontal lines. Okay, we're going to do the vertical one first, which is x is greater than negative 2. So all we're going to do is find negative 2 on the x, which is right here, and we want all of our x values to be negative 2. So there's our vertical line. Now, which side of the line do I need to graph? Am I looking for bigger x's or smaller x's? According to this, I'm looking for bigger x's. Well, bigger x's are located on this side of that line. So this is the half plane that we would shade. To do the y one, which is a horizontal line, it's got an equal to, which means I have a solid. I need to graph that one at positive 5. 1, 2, 3, 4, 5. So that point would be here. So I need to put and draw our horizontal line. So there's our horizontal line. Now we are looking for y's that are smaller. So the y's that are smaller are actually underneath the line, which would be in this direction. And you can see we have a little bit of overlap when we put two graphs on there. And that kind of leads into our systems of inequalities. So if we were graphing two inequalities at the same time, then the solution to the system would be any place on the graph where the shadings overlap each other. So here's our first system. We're going to graph the system, and then we're going to find the region where they both overlap. So the first thing I do is rewrite this one into slope-intercept. So y is going to be less than or equal to negative 2x plus 6. So my first dot goes at positive 6. 1, 2, 3, 4, 5, 6. And I apply a negative 2 slope, so down 2 over 1, down 2 over 1. And that is a solid line. And then I got to decide which side of that line do I shade. Well, we're looking at y's that are smaller, so that would be on the lower side. That would be this side of the line. Then I got to rewrite this one in the slope-intercept form. So I'm going to multiply by a half on both sides. So I'll get y is greater than 1/2 x instead of x divided by 2, because I want to see a slope. My slope needs to be a fraction, which would be a 1/2. And of course my y-intercept is plus 0, so my line actually goes through the origin here. But I have a 1/2 slope, so that's up 1 over 2, up 1 over 2. And that one is a dotted line because it does not have an equal to, so we're going to go ahead and draw through our points. And now we got to determine which half plane do I shade. Well, again, I'm looking for y's that are greater than, so that would be above the line, which would be on this side of the graph. But you're going to see where the shading actually overlaps. It's where the blue and the red lines intersect. So my solution would actually be this region right in here, because that's the only place where they overlap. And keep in mind, though, that the line down on this portion is not part of the solution because it's dotted, whereas the line up here on this side is part of the solution because it's solid. Here's another one where we have to graph 3 of them, or 4 of them. The first one is x is greater than 0. So that is a vertical line at 0. That means that we're talking about the y-axis. So that shading would be greater than 0, which would actually be on this side of my y or x is greater than 0 line. And for the y is greater than 0, that'd be a horizontal line at 0. So I'm looking for solutions that are greater than, which would be on this side. And you can see we have some overlapping. So far our solution only exists in quadrant 1, but I still have to graph the other two. So I'm going to put them in slope-intercept. So I have 2y is less than or equal to negative 3x plus 12. Divide everything by 2. Y is less than or equal to negative 3 halves plus 6. So I go to plus 6. 1, 2, 3, 4, 5, 6. And I go down 3. 1, 2, 3, and over 2. Down 1, 2, 3, and over 2. And that is a solid line, so I need to draw that one. Okay, but that one is shading below, so that would be on this side. And the next one, I'm going to move the x over, and that's going to give me a negative 2y is greater than or equal to negative x minus 4. Then divide everything by negative 2, so I get y is now divide everything by negative on both sides. My inequality needs to change, flip, so it needs to become less than or equal to. Negative over negative right here will give me a positive 1/2 x, and I divide this one by negative 2, and I get a positive 2. So I'm going to go up to 2, which is here. That's my y-intercept. Then I'm going to go up 1 over 2, up 1 over 2, and then draw my line through there. And it looks like my dots were off a little bit, so I should have been right here. My slope was off. Okay, so there's that line, and I want to look for the area that is smaller. So smaller than that would be on this side. Now if we look at it, we have a line that goes this way, a line that goes this way, the vertical line this way, and the vertical line or horizontal line that way, and the only place where everything overlaps is in this little region right in here. It's not even a half plane anymore, it's smaller than a half plane, but it does contain an infinite amount of solutions. Here's a special example where we have absolute values. So we're going to graph these. These are both going to be vertical and horizontal lines. So the first one is going to be x is less than 4 and x is greater than negative 4. Remember, absolute value, we let one equal to positive, one equal to negative, and because of the inequality sign, we switch. So we have a positive 4 and a negative 4 vertical line. So positive 4 is here and negative 4 is here. And we're going to draw my vertical lines through both those points, and they are dotted. So there's my first vertical line, and now my second one. Now the shading occurs in between. We want x's that are smaller than 4, which is this side, and we want x's that are greater than negative 4, which is this side. So the shading only occurs between these two dotted lines. Do the same thing with the y. So y would be less than 5, and y would be greater than negative 5. So we have two horizontal lines at 5 and negative 5. 1, 2, 3, 4, 5. There's the point from my first line. 1, 2, 3, 4, negative 5. There's the point from my second line. Now draw my horizontal lines. And there's my first horizontal line. And my second one. And there's my second one. And for this one, we are looking for x's or y's that are smaller than 5, which would be on this side of the line. And the bottom one, we're looking for y's that are greater than, which would be above this side. So the solution only exists in this little rectangular region that gets overlapped by both sets. And remember, we're talking about dotted lines, so the dotted lines themselves are not part of the solution, only everything in between them.